Alright, so coming back here and finishing up the notes. So I guess we call this day 2 on the notes to be able to do worksheet 11.5A. So this is day 2 on this. So the first day, just kind of reviewing how to do conics and all that. So let's come back real quickly and connect this to parametric. So this is what we're finally able to do here. We want to convert conics to parametric. Okay, so it's the ability to be able to track something from one particular point, which is going to be your focus, and how that is accomplished. So let's start off with a parabola. So y equals, and they usually use a, but we're using a in different things. So just say some kind of number x squared. So you have a parabola that is traveling, let's say, in this direction. And basically we found how to find the focus, and there's the same correlation, a line down here called the directrix of y equals the same value there. Now to find that is the distance from your vertex to your focus, and your distance from your vertex to your directrix. That distance came up with 1 over 4p. Okay, and that would be from the number that you have here dumping in to what p is. We had one way of remembering Eka, which basically is some way to remember that eccentricity is c over a. And then your directrix can also be found by y equals a squared over c. And then the other piece that you will need to know here is your total distance from your focus to your directrix. Okay. Now, once you have that, to graph any conic equation in polar. So again, we're graphing from a single point. The equation is this: R equals ED, or your eccentricity, D, which is your total distance, divided by 1 plus or minus E, your eccentricity, sine of theta, or if you want to go around using a different trig function, ED, eccentricity times your distance, 1 plus or minus E cosine of theta. Now, the plus or minus piece here, one there, okay, that determines the direction of the directrix. Okay, whether it's on the left side or right side, above or below. Okay, and we'll graph those out so you can kind of take a look at that. All right, so let's start off with an example here. All right, so let's start off with y equals 1/8 x squared. Now, yes, we did this on the previous video, so hopefully we can go through it very quickly in terms of the same things that we found in the last video. So we got a parabola, and it's very flat since it's 1/8. So now, in terms of our distance remember is 1/4p. So therefore we have 4 times 1/8, and we got 2, which means my focus is 0, 2. My directrix is y equals -2. Okay. My eccentricity, my Eka. Now remember, on a parabola, A equals C. They are both the same. So therefore, it's both 2/2, which is 1, and the eccentricity should always be 1 for a parabola. Otherwise, you're doing something wrong. But let's take the next part, the directrix. Is A squared over C. So therefore we get 2 squared over 2, which is 2, which matches that, which it should. Now my total distance, easy to find here, your focus from your directrix, so basically 2 plus 2, so there's 4 units apart. That's basically your D into your equation. So to graph out this from a single pole, so what I'm going to do here is I'm standing on my focus. Here's my point. It could be like, say, Earth, and there's a satellite dish rotating around. Or I mentioned like a radar station, and you're tracking a plane traveling in this parabolic function here. Like so. To graph that out from a single location, it would be R equals 1 times 4. So this is my E, and this is my total distance, over 1 minus 1. So again, there's an E sine of theta. Now, since I use the negative, my directrix is below the graph. So what I want you to do now is stop this video, grab your calculator, plug this into your graphing calculator, and take a look in terms of how it's being graphed. So you'll see that this is actually the 0, 0 mark, the focus is, and therefore it's tracking from there, and where the directrix is and all that. Okay, so stop this video, graph it out, take a look at it, absorb what we just did, and when click it, and then we'll move it on to the next problem that we did on our notes in another video. Alright, so hopefully everything turned out alright on graphing those out. So now let's graph out x equals y squared. Okay, so this is not a function in rectangular, so we can't graph it out. But we can sketch it out. So again, it's going through here, the distance, 1/4p. So 1 divided by 4 times 1/4 is 1 unit. So that would mean my focus is 1, 0. My directrix is x equals -1. Again, this is the same problem we did on the previous video. My eccentricity, C/A, my Eka, 1/1, which is 1, so that's good. My directrix, A squared over C. So 1 squared over 1, so 1, which checks. If I had now my total distance, 1 plus 1 is 2. Distance from your focus and your directrix. So a total of 2 units apart. Okay, so graphing this out is y equals now 1 times 2. So again, there's my eccentricity, my total distance. 1 minus 1 times cosine of theta. Okay, so again, that's my E there. And the reason I chose a negative is I'm going to make my directrix is to the left. All right, so now we can graph out, even though we couldn't do it in rectangular, now we can do it in polar because we're just graphing from a point. So now as it moves, you can see this object is moving, and we can track it from a single location of its movement. Okay, so again, I want you to stop this video, plug this into your calculator, and make sure it's in radians, by the way, and see if you can get it to work. Okay, then come back, and then we'll do an ellipse. All right, so hopefully that worked out for you. So another problem we did on the previous one is graphing out an ellipse. And say we have x squared over 25 plus y squared over 9 equals 1. So we had a equals 5, b equals 3. My focus, c squared equals 25 minus 9. C was plus or minus 4. So graphing this out on the previous video, we had 5 on the x-axis, 3 on the y, and that. And my focus is right there, 4, 0. And here my focus was negative 4, 0. Okay. All right, so the other things that we found. So now we know what our C and A are. So my Eka. So my C would be 4 over 5, which should be less than 1 for any ellipse. So if you get greater than 1, that means you're doing it for hyperbola. Okay, then my directrix is A squared over C. So that would mean 5 squared over 4. We got 25 fourths. And we got 6 1/4. So therefore, now we know in terms of whether it's be a positive sign or negative cosine. Now I could also do it for this one over here, but that depends on whether you want to use a positive or negative in terms of your directrix. So I'm going to use on the bottom, 1 minus e cosine theta. Okay, so that would mean it's going to be on the right side. So I'm going to be standing here on this focus, and the object is traveling around in elliptical format. So basically I'm using this piece here. Okay. All right, so if I wanted to use the other focus, then I'd have to use the other directrix, 1 plus, and I would have that. So I'd be on the right side of that. All right, total distance. Okay. What was it? Oh, there. So we had 6 1/4 minus 4. So we got 2 1/4, or 2.25. All right, so to graph out an ellipse, using the same equation. So R equals And I'm going to use this, so I'm going to just say 0.8. So there's my eccentricity. My total distance, 2.25. And I'm going to go 1 minus 0.8 cosine of theta. Okay. So again, stop this video, graph it out, play around with it, change this to a positive. So you can see how to use the other focus if you want in terms of how to track it. Okay. All right. Do that and we'll come back and look at going backwards on this. All right, so let's take a break from doing that and let's work backwards. Okay. All right, so when you're given, let's say, the directrix of x equals 25 force, and let's say, and your eccentricity of 4/5, just take a look at your two equations that we've been using. So let's say my ECA, E over CA, and my directrix of A squared over C. So if I plug in and say, okay, my eccentricity is 4/5 equals C over A, and my directrix is 25 force equals A squared over C. Treat it like when we were converting equations in terms of foot-pounds to feet meters or whatever, that if I multiply, let's say, 4/5 times 25 over 4, that would be the same thing as, say, taking A squared over C times C over A. So what would happen if I did that? Well, my C's cancel out, when my A's cancel out, and I have my A value. So therefore, what's my A value? Cancel out, you have 5. A is 5. So if you have A is 5, well, then you can come back up and plug it in. So let's say we have, using this now, 4/5 equals C over 5. That means C would be 4. Okay. Once I have that, then I could say, well, if C squared equals A squared minus B squared, I can then plug that in, and C squared, I have 4 squared equals 5 squared minus B squared. B squared would be 9, and B would be 3. So that is if it was, oh, that was, excuse me, kind of jumping again. That would be, oh, my notes kind of got out of whack a little bit, but all right. Dang it. My notes got out of whack. Got ahead of myself. So basically what I did here was a hyperbola. So this would be x squared over a squared minus y squared over b squared equals 1. So we're going to graph this one out here in a second. So actually it just should have been flip-flop. All right. All right. Yeah, like I said, got ahead of the game. I was wondering why that was there. All right, so let's come back and let me see here. Let's graph out one more hyperbola. Yeah, let's give me a lot of room here. All right, so okay, so let's say x squared over 16 minus y squared over 9 equals 1. Okay, so my A is 4, my B is 3, So therefore C squared equals 16 minus 9. C is, plus 9. C squared is 25, and C is 5. So, and we already found the slope and all that. So we have my vertex is at 4. Again, I'm just going off on the previous video here. We had up 3, 1, 2, 3, 4. Like so. All right. So let's go ahead and get this graph. So let's start off with my Eka. Here we're A. C is 5. A is 4. Notice it's greater than 1, which it should be. My directrix. A squared over C. So 4 squared over 5. So I have 16/5. My total distance here, that would be 16/5 minus 5/4. So plug that in your calculator, you should get 39/20. Okay. Now my directrix, if you graph this out here, so we can kind of determine which, if we're going to do a positive or negative cosine. Where's my directrix? So this would be, what is that, 3 1/5. So 1, 2, 3 1/5. So therefore, this one here. So if and my focus is here at 5, 0. So this is the point that I'm going to track things as it moves. So if I want to use this focus, I would use a 1 minus e cosine theta, and therefore my directrix would be to the left of what my focus. If I wanted to use this other directrix, so therefore if I have a focus here of -5, 0, and I wanted to use this focus so I can track the movement from here, I would use 1 plus e cosine theta. So that therefore the directrix would be on the right side of my focus. So I'm going to graph out this one here. So therefore my equation would be 5/4 times 39/20. So again, here's my E, here's my total distance, divided by 1 minus 5/4 cosine of theta. All right, so again, pause the video, graph out both, change that from 1 minus 5/4 to 1 plus 5/4, so you can see graphing of the other two, and see how you do. Okay, and then come back. What else? All right. So do that and come back and we'll do a couple more other things here. All right, welcome back. Hopefully everything got graphed out all right. So let's begin working backwards. Sorry about my notes, kind of got out of whack there. So let's take another example here. Let's say my directrix, is x equals 4. Let's say my eccentricity is 1/2, which means if it's less than 1, that would mean that we are graphing out an ellipse. So your eccentricity always tells you which one you're doing. So if you look at your two equations, eccentricity, your Eka, and your directrix of a squared over c. So if you have 1/2 equals C over A, and your directrix is 4 over 1 equals A squared over C. Think of it again like converting. So if I multiply these two out, so if I have 1/2 times 4 over 1, that'd be the same thing as C over A times A squared over C. So again, the C's cancel out. I have my A. My A would be 2. And therefore, if my A was 2, coming back here, and coming over here, so I have 1/2 equals C over 2. C would be 1. Okay. And now coming to that next piece then, since this is an ellipse, I know it's going to be C squared equals A squared minus B squared. So I have 1 squared equals 2 squared minus B squared, which would give me B squared equals 4 minus 1, and B would be the square root of 3. Therefore, equation of my ellipse, so it'd be x squared over 2 squared, there, plus y squared over my b squared, so root 3 squared equals 1. Okay, and there we have it. All right, one last thing I want to throw in here. So let's say, coming back here, and I give you your foci, C equals 1, and your directrix is x equals 4. So if your focus and directrix, that would mean then your total distance would be 4 minus 1 would be 3. What else? Oh, what else am I going to give you here? And let's say your eccentricity here is 1/2. So graphing this out, we have R equals, say, 0.5 times 3 over, and let's say 1 plus 0.5 cosine of theta. Now, since this is less than 1/2, you know it's going to be an ellipse of this thing. Plus, so your focus, I think, would be there. So you graph it out. Now, what I want you to do now, though, is now I want you to turn it and graph it at an angle. Or graph it out like an angle like this. So how would I rotate an object from a single location? Because not everything is going to go perfectly like horizontally or vertically. Some things will come in at some form of angle or rotate around as an angle. Well, all you have to do is do that. That converts your rotation. So let's say if I want to rotate it by, let's say, pi over 4, all I have to do is go 0.5 times 3, and go 1 plus 0.5 cosine, and whatever angle measurement I want to use. In this case, it's, say, pi over 4. That would rotate it. So what I want you to do now, and this is all we're going to do here, there's nothing left, is grab your calculator, play around with your angle measurements. First off, graph the first one, see where your focus is, your directrix is. Then switch in, throw your angle measurements, and start, go pi over 4, pi over 6, pi over 3, pi over 2. Do different ones and see how it all works. Okay. Then also go back and try some of the other ones that we did, of the parabolas and hyperbolas. Plug those back in your calculators and rotate those at different angles. Okay. So have a little bit of fun with your calculators, and hopefully this is making sense. You got your couple formulas there to remember. Okay, you got to remember your ECA, C over A, your directrix, okay, which would be A squared over C. Remember on your total distance on a parabola, so this is on a parabola, you have the first unique one that you got to remember, your total distance. Write that down. Distance equals 1 over 4p for a parabola. And that would mean your C equals A. So that's unique to be able to get that information. The other ones, the C and A is given here. You need to be able to find your total distance, and that would be your distance from your focus and your directrix. Okay. And then once you have that down, then all you have to do is remember your eccentricity times your total distance, so that's total distance. And then you have 1 plus or minus, and then depending on which trig function you want to do. If you want to go around the x-axis, the y-axis, you either go sine for around the y, cosine around the x. So they say cosine of theta. And if you want to rotate it, okay, just add something to that. When you add it, it rotates things around. Okay. All right, so those are the general equations that you got to keep track of, and hopefully it's starting to make sense.